Anytime we talk about solubility, it's a good idea to know how we can adjust it. This is screencast 11.3, and we'll be talking about one of the main ways to adjust the solubility of a solute in a solvent, and that is by applying Henry's law. By the end of the screencast, you should be able to determine if solubility increases when solutions are heated. The answer might surprise you. And what about when gases are heated? Does the solubility increase or decrease? For example, if carbon dioxide is dissolved in water. Finally, what's the deal when you pressurize a solution? Should it become more or less soluble? Another thing to consider once you learn Henry's law is why isn't it S1P1 equals S2P2, where S and P are solubility and pressure? And we'll find it's actually S1 over P1 equals S2 over P2. You might ask yourself why. And as a practical application, what happens to solubility when the pressure is triple? The practical application of Henry's law. This is screencast 11.3. How do we adjust solubility? Well, one way is to apply Henry's law. A simpler way might be to ask yourself, why can't we just heat it up? And here's some data when solutions are heated. Here's your solute. They're all dissolved in water. Notice that in most cases the solubility increases, but in the case of cerium sulfate it goes down. Therefore, the best answer is not always. However, if we pressurize a solution, like they do with soda, the solubility of that solute generally, actually universally, increases. Therefore, solubility is proportional to pressure. That must be as expressed as S1 over P1 equals S2 over P2, where S1 and P1 are the original solubilities and pressure respectively. S2 and P2 are those final solubilities and pressures. Okay, so we've learned that when we heat a solution, usually that's going to make most solids dissolve more, so they become more soluble. But think about gases. What happens when you take that cap off and heat that soda? It will go flat. Most gases come out of solution when they are heated. This has global ramifications because that must mean that the solubility of a gas increases when it gets cold, the temperature gets cold. Therefore, at the poles, where the oceans are pretty much always cold, there's more dissolved oxygen. More dissolved oxygen means more life. More life means more plankton. More plankton means more fish that eat plankton, more whales, and you find that the seas are full of life at the poles. Let's do a couple quick calculations. If the solubility is 1 gram per liter at 1 atmosphere and we bring it up to 2 atmospheres, well, that solubility should double. And here's when you'd have to calculate. We're going from 5.6 atmospheres down to 1. That solubility number right there must go down by a factor of more than 5, so that number should be less than 1. You plug into the equation, and you find that all we have to do is divide 3.45 divided by 5.61, because S2 over 1 is the same as S2. And we get a final answer of about 0.6 grams per liter for the solubility at 1 atmosphere. This is screencast 11.3.